Hello everyone, and I thought it'd be a good idea to go over the homework that we had in our second week. So what I'll do is I'll walk through it and I'll talk about how to get the answers that should have been the right answers on this thing. So let's get started. So for question 1, you bought 2 shares at the start of the year for $40 a share. They pay a $1 per share dividend, and at the start of the year, you bought 1 more share for $45. At the end of year 2, shares pay 1.5, and at the end, you sell all your shares for $50. What is your time-weighted return? Okay. So for this, initially, you're purchasing 2 shares for $40 each. So your cash flow is going to be two shares times, well, negative 40, so negative 80, and your price per share is 40. Next, or rather the next year, you receive a $1 dividend per share, so we have 2 shares times $1 per share, and we also buy an additional share. So that next additional share was $45. And so our total cash flow is negative $43. And finally, in year 2, we have a 1.5 or $1.50 dividend. So this year we have 3 shares because we have the original 2 shares plus the one we bought in year 1. So 3 times 1.5. Plus, we sell our shares all for the share price of 50, so 3 times 50. So there we go. If we want to know our time-weighted return, this isn't going to help us, but what we can do is calculate the time-weighted return using the price per share in each period. So we had our price per share at the beginning. We know our price per share at the end of year 1 is 45. And we know our price per share at the end of year 2 is 50. And to get our return in each period, what we can do is we can take the holding period return formula. And that holding period return formula is the price at the end of the period, so end of year 1, minus the price at the beginning of the year, plus any per share dividend. And in year 1, we received a $1 dividend, so plus 1 divided by our price at the beginning, $40. So our return in year 1 is 15%, and our return in year 2 is just the $50 at the end minus the $45 at the beginning, plus the $1.50 share or per share dividend divided by price at the beginning. So about 14.4%. Now to get our time-weighted return, what we need to do is we need to use the geometric return formula. And for that, I'm just going to add 1 to each of these returns. And then I'm going to use the geomean function. So equals geomean, highlight our 1 plus returns, and then subtract 1 because I added a principal to get these 1 plus returns. And so our time-weighted return is going to be about 14.72%. Next, for our second question, same data, but now we're looking for the dollar-weighted return. And the dollar-weighted return is just the internal rate of return using these cash flows. So I'll use equals IRR and highlight my stream of cash flows, and there we go. It's about 14.67%. So let's leave it out. Okay, next, use the FSRC function to screen for funds. So we have a couple of characteristics that we're looking for. The first 2 are going to be pretty straightforward, or at least one of these is going to be straightforward. Fund primary share class, yes. That's going to be the default. We also want funds whose class focus is equity, and they're domiciled in the US, and their manager location is in Indiana. Alright, so let's get started. Also, these need to be active funds. So I'll go over to Bloomberg, and I'll use the FSRC function to screen for funds. And notice here that already we have two screens. So the funds that we have here, about 417,000 are active, and about 138,000-ish we have the primary share class. Next, we want to select those funds whose primary asset class is equity. So I'll click that and click Update. Next, we want funds whose country of domicile is the US. And then we also want funds whose manager is located in Indiana. Not that many of those, so we don't have that many funds to choose from. So grand total, we have 27 different funds that meet our requirement. Okay, next. What is the year-to-date Sharpe ratio of our student-managed investment fund if the pre-X US is the benchmark? Remember, the pre-X US, that's our Thompson, our T. Rowe Price, S&P 500 fund, so it essentially tracks the S&P 500 index. So what we can do is we can go over to the port function. Since we've already created our portfolio, what I'm going to do is make sure that our Smith is our portfolio of question in question, and then we'll load our pre-X as our benchmark. And then we'll go over to performance. I'll just call it performance. And then we'll go over to statistical summary. We'll just give that a second. Sometimes it's a little slow. And here we go. Okay, so we've got everything here. Our assignment should have been completed about a week ago, so I don't think it's going to make that big of a difference, but we'll load this as of, we'll say, August 30th. So when we do this, we're going to see that we're going to get, what we're looking for is our Sharpe ratio, and then we'll also look for Jensen's alpha, information ratio, and trainer measure. So here, if we're looking for the year-to-date statistics, here's our Sharpe ratio, year-to-date, about 2.47. Jensen's alpha, negative 3.29. This is in percentage terms. Information ratio and trainer measure. Okay, so all of those you could have entered right here. But we also have question 6 that asks us, based on the Smith's Jensen's alpha, how has the portfolio performed over the year-to-date? Well, because we have a negative Jensen's alpha, negative 3.29%, what that indicates is that our portfolio actually underperformed the market over the year-to-date. It underperformed based on its level of market risk. Or in this case, since we're comparing our portfolio to the benchmark that is the pre-X, we underperformed by 3.29%. Okay, next question. Use the VAR comparison function and determine which VAR calculation yielded the largest 1 month percentage return on 8/27/2021. So what I'll do is I'll click on VAR and go to VAR comparison. unfortunately it's a little slow, but I also need to load it for the 27th. Okay, here we go. Okay, so we're looking for the largest 1 month, so I need to change this as well. A month is defined as 22 days by most investors, because there's about 22 days when the market is open. And hopefully it should come up. Maybe. Okay, here we go. So here, our largest 1 month expected loss in return percentage. Sorry, I need to change this. Should be, well, give it a little more time. Sorry, I usually like these videos to be extremely concise. But here we go. So our largest potential loss based on these models that we're seeing would be our historical 1-year VAR. Remember, this would be a negative though, so this would, in terms of actual magnitude, just absolute value, it would still be the largest, but in terms of least negative, it would be Monte Carlo simulation. I honestly thought that I worded this question poorly, so obviously you got full credit if you turn in the assignment, but technically the correct answer should be historical, historical 1-year simulation VAR. 2-year VAR. So none of these really would have been the correct answer, but yeah, poorly worded, poorly written. Sometimes that just happens. That's my bad. Okay, next, what was the 1 month VAR of 0.05 for the Student Managed Investment Fund on that date? Well, to get that, what we can do is we can go back to the main view, and I believe we're looking for the profit and loss. So here, what we'll do is we'll change that to profit and loss, so this is just the dollar value. And here we go. Our VAR indicates that over the course of a month, if we had a really bad month at the 5th percentile, we can expect our portfolio to lose about $146,000. So that would have been the correct answer. Okay, next, use the port function and determine the 1-year tracking error between the Smith and the benchmark. So we'll go to tracking error, and we'll give that a second. And we want to go over to summary. And here we go. So we have a lot of data here, but the thing that we're interested in is the tracking error. And so with a lot of buttons and numbers in Bloomberg, if you just highlight over a certain area or a certain metric, it'll often give you an indication of a more detailed label or even describe how that is being calculated. So here, our tracking error is 3.05%, which does correspond to an answer here. Okay, next, use the asset allocation function to determine our asset allocation return between these dates. So we'll go to attribution, and we'll go to main view, and we'll need to change the dates here. So 12/31/20 to 8/27/21. Now, unfortunately for this one, depending on whether you had something slightly off, or it might have even, for whatever reason, just have been, I don't know, I hate to admit, I don't know why some people were getting answers that were different from negative 4.67%, but the answer I had in mind when I wrote this question should have been negative 4.67. So what we have here indicates that your asset allocation return for the student managed investment fund was negative, indicating that the previous classes who have managed this fund misallocated funds across different industries, and they underperformed overall by negative 4.67%, and their security selection return was actually negative 0.43%. So even inside those different industries, or these are sectors, they underperformed by about 43 basis points over this time period. So not ideal, but hey, that's just kind of unfortunate. So that's that. So I believe that was the last question on this assignment. So if you do have any other questions about this assignment, please feel free to reach out. Obviously, I want to make sure that you understand this material for the first exam, which we have coming up. So please reach out.